Hello and welcome to all of you from the RBS Busy Research Academy. This is the lecture number 6, and in this lecture I'm going to discuss about the evolution of the structural model in SmartPLS. Dear friends, this is the third theoretical video in the series of the SmartPLS, and my seventh video would be where I have discussed about the two important books on SmartPLS. If you find time, please watch my video also. So after that one, I have started some practical work on the SmartPLS, because I always believe that if you want to understand the SmartPLS, then you must learn, you must understand some concepts of the SmartPLS. So that's why this is the sixth video where I have discussed all the necessary concepts which are important to understand when you are running the SmartPLS. Because in this way, you will be sufficiently able to understand what you are doing and what is going to be happen when you are working in SmartPLS. So that's my objective, to make you able to understand the SmartPLS efficiently. My name is Dr. Rahmat Suru, and I'm from Shabati University, Pakistan. I'm happy to inform you that I have completed this online course from the PLS-SEM, Hamburg University, Germany. So in that one, I covered all these courses in this one, and that's why this certificate has been awarded to me from the PLS Academy. Now, this is the continuously I'm discussing this model elements in the video number 4, which is on the reflective, video number 5, which is on the formative latent variable, and this is the video number 6. Continuously, I'm discussing this one in these 3 videos, because this one is very important. Once if you understand this whole concept, then it's very easy to work in the SmartPLS. So in that one, last 2 videos, I discuss about the reflective model and the formative model. If you find time, please watch these 2 videos. So here there are the 2, basically the models are there. The measurement model, which alternatively we call as a outer model, and another is a structural model, which alternatively we call as a inner model. So here, when you talk the measurement model, it has the 2 types. One is the reflective model and the formative. When we combine the reflective and formative, it becomes measurement model. But in this video, I'm only talking about the structural model to test whether either a structural model is valid or not. In that one, what we are going to do in the structural model, let's see. This is the inner model. Okay, where the 2 types are there: outer model, exogenous, and outer model, endogenous. So now exogenous means our independent variable, and endogenous means our dependent variable. So this is our structural model, where we are going to find out the relationship or the relationship of among the different latent variables in the inner model. Now, this is the stage 5 evolution of the measurement model, which we have already covered. And that one we have covered some of the discussion on the reflective measurement and formative measurement. And now in this video, I'm going to discuss about the evolution of the structural model, where I will evaluate. So these are the tools of the evolution of the structural model. So let's discuss one by one these tools in. So when we talk about the evolution of the model, what do we mean by the evolution of the model? The first one is about here we are going to evaluate the relationship between the latent variables among the different latent variables in the structural model, where we are going to evaluate with the help of the path coefficients, where we are going to find out some path coefficient in that one. So here you are, let me say, we are watching one image where the path coefficients have been provided in that one, and then these path coefficients are mentioned through the P. So in this one, you are finding the P and P23, like this one, different P's are there. This PR is a path, and the value which is given here, that is a coefficient. That's a path coefficient, is being known as a P. And then this we can measure with the help of the PLS-SEM algorithm. After algorithm calculated, construct score are being provided to you, and the scores are used to estimate the each partial regression model. Every this regression model we can compute with the help of the construct scores. In the, as you know, the two parts are there. Path models are made up of the two elements. Structural model, which we are discussing right now, and alternatively we call is an inner model, which describe the relationship between the latent variable. What is the relationship between the among these three latent variable? So now that we can measure with the help of the structural model. And then other is inner model. Other is a outer model we call is a measurement model. So this is our measurement model, and this one is also our measurement model. What are these? Which describe the relationship between the latent variable and their measures. This is our latent variable, and these are its measures. So in the measurement model or outer model, we are going to check out the relationship. What is the relationship between the one latent variable along with the several indicators which are there. So these are the two type of the structural models are there, are path model there. 5 tools to assess the structural model. Let's discuss one by one these steps. The first step is our collinearity issues. Dear friends, collinearity is always a big problem for the data. Different problems are being occurred due to the high collinearity among the different, due to high quality among the between the different variables. So this cause issues. So that's why collinearity issues are very important to address. How to address these collinearity issues? Two values are there. Already, I think you know about the tolerance and the VI values. These are the two tools through which we can address the issue of collinearity. And we can also know either the collinearity persists in my data or not through the the values of the tolerance and the VI value. And then in the context of the PLS-SEM, tolerance value when it is 0.2 or less than 2, that's fine. It means in this when your data there is no collinearity because the value of tolerance is 0.2 and the VI value 5 or higher. Okay, so now here more one guideline is there that if the VI value is less than 3, that's wonderful. But if it is more than 3 and less than 5, okay. But if it's more than 5, then it's a problem. And so we can say that the potential collinearity problem is there. The reason is that the estimation of path coefficient in the structural model is based on the OLS, ordinary least square regression. Path coefficients which we are going to calculate, these are depending on the OLS regression, where endogenous latent variable on its corresponding predecessor constructs. Like the endogenous variable and the corresponding predecessor, like we can say that these are the independent variables which are connected with the endogenous. So we have to check we have to estimate the path coefficient with the help of the OLS, ordinary least square regression methods. This is a collinearity. This is the example number 6 from this book, where we want to check the collinearity among the different our latent variables. These are our different latent variables. So we want to check either there is a high correlation between any two variable or amongst different variable or not. So in this one, this is the path P13, path number 13, path number 23, path number 24. So here we have to find out that, for example, if there is a relationship, high relationship between the Y1 and the Y3, like that, if its tolerance value is less than more than 0.2, if it's the like the VIF is a more than 5, that means that there is a collinearity between this one, and then we can check the collinearity from the Y2, Y3, and the Y2 and Y4. So different these are the structures or models are there where we have to check out their collinearity among all these ones. And then path coefficient, running PLS-SEM algorithm to estimate the structural model, the path coefficients, and the hypothesized relationship among the constructs. Hypothesized relationship among the construct means that this is the one construct, this is another construct. This like the arrow, This shows the relationship between the y1 and y3. Now it is our hypothesized relationship. Here is our hypothesis. For example, that we are making a one hypothesis that there is a significant and positive relationship between the employee motivation and employee performance. So now this is the for example, this is the performance, this is the motivation. Now performance depends on the motivation. So here we have drawn a one type of the hypothesis. So now this hypothesis is one path also. This is another hypothesis y2 and the y3. This is another hypothesis y2 and the y4. So these type of the path we are required to check either these paths are significant or not. And then their path, the value of path ranges from the -1 to +1. So the minimum would be the -1 and maximum it will go to the +1. So now the coefficient value will be in this range. Path coefficient close to 1. If it's a close to 1, it means there is a highly strong positive relationship between the two variables. And then, but it is a positive. Now, if there is a 0, it means there is no relationship. We can say if there is a weaker relationship between the two variables. Very low value close to the 0 are generally not statistically significant. So now, if the relationship between the two values or two latent variable is 0, there is no relationship. On the other hand, the relationship is also insignificant, statistically insignificant. And then when interpreting the results of path model, we need to test the significance of the all structural model relationship. Whatever the structural relationships are there, we have to check their significance. That statistically, either these are significant or not significant. So what are the statistical values against which we can check out their significance? Now, these we can test with the help of the t values and the p values. Are bootstrapping confidence interval. So normally we check these relationship or path coefficient, either these are significant or insignificant through the t values and the p values. These are the two tools are there. And then the goal of the PLS-SEM is what? Not only the significant path coefficient, not to find out the significant coefficient data which are significant and which are not significant. That means the relationship between the two variables, either that is significant or that is insignificant. That's not only the objective of the PLS-SEM, but also to find out the significant and the relevant effects. Now, the two objectives are there of the PLS-SEM. One is to identify the significant coefficient, and other is a relative coefficients or relative effect of the one independent one variable on another variable. And then after examining the significant relationship, it is important to assess the relevance of the significant relationship. Once if the relationship is significant, then the next thing is to find out that either that is relevant or not. Now, so as in the last slide, we discussed about the p value, we discussed about the t value. So now here we are discussing about the p values. Now, for example, our hypothesis is a two-tailed hypothesis. Normally H0 and H1. So when we have the two hypotheses, H0, H1, this is called the two-tailed test. So in this one, our significance level, when our significance level is 10, the minimum that should be 1.65. If it is higher than 1.65, that means if the t value is higher than 1.65, that means our relationship is significant. If when the p value is 5% and if the t value is higher than 1.96, then again it's significant. When our p value is 1% and if it is t value is higher than 2.57, then again it is significant. If it's not higher than this one, then all our relations are insignificant. Now, normally we have the three level of the confidence interval level. One is 90%, one is a 95%, and the 99%. Mostly researchers they are using the 95% confidence interval. So this is in case of the two tailed. And when you have the one tail, a hypothesis, what to do. In this one, 1.28 confidence, when your confidence interval is a 10%. Alternative, we can say that when you are going to check out the confidence interval at the 90%, then the minimum T value should be higher than the 1.28. If it's not higher than the 1.28, it means the relationship is insignificant. Now, the relationship may be positive, may be negative, that's another story, but the relationship is insignificant. In case of the 5% p value, then it should be t value should be higher than 1.65. In case of the significance 1%, or alternatively we can say 99%, then the t value should be higher than the 2.33. Alternative, otherwise we can say that the relationship may be positive or negative between the two variables, but the relationship statistically is insignificant. And then what, in case of marketing, usually researchers use the 5% confidence interval. Dear friends, so whatever I'm telling you, these are the rule of thumb. Okay, so now some of the deviations are also there. If you are able to justify your deviation is there, so now then you can use that benchmark. It's not a problem, because we are dealing in the social science. We are not dealing in the natural science, where the rules, regulation, laws are already universal laws are there, and we cannot go against them. But here, some of the question is available there where you can go against all these benchmarks, where you can also design your own benchmark. You have to provide some justification over there. Always apply. For example, in the consumer research, like here is a consumer research. Normally we use the 1%, or in case of the experiment. So if we are working doing any experiment in the social science, although rarely people work on the experiment, mostly we work on the survey. If this is the case, if you are working on the experiment, then you should choose the 99% over 95%. In the consumer research, again, the people are working on the 99%. When the study is exploratory in nature, then we have to work on the significance level should be 10, like the 90% confidence interval over there. But again, it is a rule of thumb. Then even you can work on the 95%. But logically, if you think that we are exploratory, working on exploratory research, so we are not sure what is going to happen. So if this is the case, I think that 10% or 90% confidence level is good, because if you are choosing 95% or 99%, it is so conservative. So when you are dealing with the exploratory research, then do not follow those benchmarks which are highly conservative. The ultimate choice of the significance level depends on the study objective. Either you are working on following two-tail or one-tail hypothesis, but ultimately the significance level means the 10%, 5%, or 90% depends purely on the study objective. Now, here is some guideline is there that these are our variable are there. Okay, so here this is our path coefficient. This is our P shows the path, and this is our 25%. 0.25 is our value of our coefficient. So here there are the three coefficients are there. Now, for example, here this exhibit I have taken from the page number 172 from this book. Exhibit 6.3 shows the example of a structural model where the path relationship from P14 to P14 from the Y1 to Y3 have a value of the 0.25. Now, this is a Y1 and this is a Y4, and it has a value of the 0.25. Now, how to calculate this path and how to know either that is significant or not? For this purpose, we have to draw the 5,000 subsample and 450 bootstrap catches at the standard error of the 0.118. And the t value is our now this is the calculation. If you follow this calculation, then we come to know that at the rate of the 5% and the t value is a 1.96, that these are significant. Or they is the from Y1 to Y4, Y1 to Y4, at least this relationship is significant. The rest of relationship, you can also check their significance with the help of this formula. So when you will enter in the practical world of the SmartPLS, so these things you will do without any problem. This is another exhibition exhibit taken from page number 175, where we are going to check out the direct, indirect, and total effects. There are three effects are there. Let's discuss now Y1 and the Y3. Impact of Y1, which is being shown with this help of this arrow. Now that the Y1 impact of the Y1 and Y3, this is the direct impact, and its coefficient is 0.20. And another direct impact is our from Y1 to Y2. But when we want to check the impact of the Y1 on Y3 via Y1, Y2, it is called indirect effect, because we want to check the impact of the Y1 on Y3 with the help of the Y2. Alternatively, we can say it is also a mediator. So this is an indirect impact. And when we are going to check the impact of all these three, it is called a total effect. How to calculate? Let's discuss. Construct Y1 and Y3 are linked by the direct effect. Now see why these two are linked directly with each other, and effect our value of coefficient is 0.20. There is indirect effect between the two construct via the mediating construct Y2. That means that this is the one construct, this is another structure, and then its impact we want to check with the help of the Y2. This time the Y2 is here working as a mediator, as well it is also working as a dependent variable. Okay, and then how to calculate the total effect. Now this is the formula where the P12 is a P12 into P23 into P23. When you multiply it, it becomes the 0.40. Alternatively, you can see the 40%. The total effect is 60%, and then through this formula, we can see the total effect is the 60%. Okay, so now in this way, we can calculate the like the direct, indirect, and total effects. Now, highly useful, and mostly the people are using coefficient of determination. This is a third step that is called, normally we can call R square. Coefficient of determination is less popular, and R square is much more popular. And this is the most commonly used measure, that is the R square. And then the coefficients. Coefficient represent the exogenous latent variable. Now, exogenous means the all independent variables, their combined effect on the endogenous. It means the combined effect of all independent variable on dependent variable. This is, in this way we can compute the R square. And then it also represents another definition, amount of the variance. Okay, in the endogenous means the dependent variable explained by the all exogenous which are linked to the construct. So now is another definition of the R square. Now these are the values of the R square, and the same R square ranges from the 0 to 1. In this one, the 0.75 is substantial. If it is higher than 0.75, that's wonderful. Alternatively, we can say 75% variance is being shared by the all independent variable into the dependent variable. If the value is more than 0.5, 50%, that's again moderate. And if there is less than the 0.5, it's a very weak. And commonly we can say if the value of R square is more than 0.5 and within the up to the 0.50, that's a substance, that's moderate. Okay, that's good. This is the one of the guideline. R square ranges from the 0 to 1. Okay. Now different guidelines are there for the different type of the subjects. For example, it's difficult to provide rule of thumb. So already 3 rule of thumbs were there, but again it's difficult to follow all these ones because of some issues are there. For example, where is R square value 0.2 are considered high the discipline of the consumer behavior. If you are working in the consumer behavior, then the 0.2 20% value of R square, that's sufficient. And then like the consumer behavior or customer satisfaction or the loyalty, customer loyalty. If you are working in these type of the area, then 0.2 or 20%, higher than 20%, the R square value is sufficient. And but researchers expect a much higher 0.75 and above. In scholarly research, the focus on marketing issues, especially the R square 0.5 or 70%, and 50% and 25% for endogenous latent variable can be considered as a substantial, moderate, and temporary. So now, somewhat, it also depends on the subject in which you are working. But mostly, what people are doing, they are focusing on all these three, like the benchmarks are there. So if you are more than 0.25, and that's okay. Again, I'm telling you that we are dealing with a rule of thumb. If you have a justification, then whatever the value you are choosing, that's okay. Then another is the effect size. So now the effect size change in R square. Now, you know that the R square, there is a combined effect of all independent variable on the dependent variable. So now whenever you are reducing or eliminating one independent variable from the model, then definitely R square will be reduced. So when the R square will reduce, this is called the effect size, or we can say the F square. So sometimes what's happened is that by mistake, we are excluding that independent variable which has a substantial impact on your R square. So if you are excluding that independent variable from the model, then definitely it has a very substantive negative impact on the substantially the F square will be reduced because of the exclusion of the very substantial, very important your independent variable from your model. And how to calculate the effect size? This is the formula to calculate the effect size. And then some of the guidelines for the effect F square. These are the, if the value is 0.02, it's a small. If this value is 0.5 or more than, it's a medium. If its value is 0.35 or higher, that's wonderful. That's large impact. And then these are some of the our effect size or F squares are there. This is our formula. According to this formula, I have calculated all these F square in this model. So this image I have taken from 172 page from this book, and this is the F square for the number one. For this one, its value is 0.12182. This is a 0.205, and this is the 0.3. Now, if you compare all these one, then the P2034, this part is the highest F square. So if you reduce this one, then definitely this substantially the value of this R square will be reduced. So if you exclude this independent variable from the model, then because it's the effect, then means the F square or the from this one, it will not be reduced substantially because it has a very meager impact or contribution in the dependent variable. This is the Q square. So mostly we are working on like the square, R square, F square, and this is the Q square. Okay, so in this one, in addition to the R square value, we are also working on the Q square, which was given by the Stone and Geyser test in 1974. Now, what it's doing, it is predicting validity of the exogenous latent variables. It is giving us the predictability of the all independent variables, and this can be computed with the help of the blindfolding procedure. This wire is indicated the model predictive relevance. Okay, so with the help of this model, this wire, we are going to check the model's predictive relevance. Q square larger than 0. If the value of the Q square is more than the 0, it means that certain reflective endogenous latent variable indicate the path model's predictive relevance. It means that if the Q square of the reflective latent endogenous or the dependent variable, if its Q square is more than the 0, it means the path model predictive relevance is being indicted or is being shown by the Q square with the help of this one. And another thing is there, important thing is that the Q square does not apply on the formative endogenous construct. It only is applying on the reflective endogenous construct. The reason is that mostly in the formative, like you are saying that we are working on the different aspect of one, like the one aspect or latent variable. further personality is there. So now the different five factors are there. They are going to make a factor personality. So this is the formative. So one factor is talking about the one trait of the personality. Another factor is talking about another trait of the personality. So all the traits, all the factors are there. So these are the different. They are talking about the different traits. So that's why they means that Q square cannot be applicable in that one. And its number is the number between the 10 and 20 should be used in the most applications. Okay. And then after this one, this is the formula of the Q square. Almost same in case of the F square. Now the Q square of blindfolding procedure represents the measure of the path model can be predicted originally from the observed values. So through this model, we can predict the path model originally from the observed values, the values which have been observed. And then the relative impact of the predicted values can be compared by the means of the measure and the Q square effect size. And this Q square effect size can be calculated with the help of this formula. Okay. Now, after discussing all these five tools to measure the evolution or the structural model, so these some of the good things are there. These are the goodness of it indices. So, dear friends, in the AMOS, because it's AMOS is working purely on the reflective construct. So there, some of the goodness of it indexes are there, which are looking here. So these the three categories are there, and more than 10 different indices are there. So we apply all these indices to check out whether our model is significantly, it's a significant, either the model is falling properly into the data or not. So here, in case of the SmartPLS, either the sum of the goodness of indices are there or not. That thing we are going to check out right now. PLS-SEM goodness of indices. Okay, an operational solution to this problem, it may be need an index for validating the PLS. So now some of the goodness of indices should be there through which we can validate the SmartPLS model globally. So in this regard, Hansler and Sardar said that they have challenged all the GOEFs. These both guys says that researchers say that conceptually and empirically through research that actually whatever the goodness of it indices are there, they are here we can say that whatever they are not able to separate the valid model from the invalid model. Okay, so that's the problem. Especially this problem is with the SmartPLS because there is no universal goodness of it indices for the SmartPLS. And then GeoFi are not applicable to formatively measurement model again because these are only applicable in case of the reflectively measurement models and does not penalize over parameterization if researchers are advised not to use this measure. There are no any goodness of indices globally accepted for the formatively measurement model, so that's why we do not use any one. And then this is the our table. This is our rule of thumb. In this, when the five tools we have discussed in this model and the benchmarks of all these five tools are available here. If you find time, go through all these one and make your memory refreshing, refresh your memory by going through all these biases or benchmarks. It is necessary or advised to you that if possible, please memorize all these one. It is in your own interest. And then in the last, basically I have discussed, I have referred this book to make this video and this chapter number 6, which you are looking here. And if you require this book, I can provide you free of the cost. Just you are required to send out an email to me at this email address. At the end, I'm thankful to you that you have watched this video completely, and I hope this video has again become useful for you. And very soon we will meet in another video. Till that time, goodbye.